Please welcome to the stage NI-CTO, Emerson Test and Measurement, Kevin Schultz.
Good morning. Well, I hope you enjoyed yesterday as much as I did. And I'm not talking about the conference party. I really enjoyed seeing your innovative solutions from engineer to enterprise. Today, we're going to do a context switch. We're going to look into the future. We're going to see how you're going to solve tomorrow's problems with a little help from AI. Now, there's no doubt the technology news cycle of 2024 has been dominated by AI, the hypes, the hopes, and the fears. So let's cut through the headlines. Let's look at the real-world impact on test and measurement and how we are going to drive the intelligent test revolution. So anytime I look into the future and think about technology in the future, I like to start by reflecting on what got us to where we're at today. What technology has shaped our industry? Let's start back at Bell Labs in 1947. They invented the transistor. Do you think they had any idea when they invented that transistor the impact that would have on the world, let alone industries like ours? Of course, that transistor led to the integrated circuit. The integrated circuit formed the semiconductor industry as we know it. What was the major output of that? The personal computer, which was then revolutionized by the graphical user interface. The world then decided, let's connect these PCs together to form the internet, and now we literally have the internet and the PC in the palm of our hands. Amazing. Those innovations are amazing, and many others, and they've redefined our jobs as engineers. They've also changed the shape of society. But I really believe the impact of AI will be bigger. Bigger than anything I've seen firsthand. Bigger than the cell phone, bigger than the PC, bigger than the internet. It will be the defining technology of our era, unlike anything we've seen before. What I grew up seeing as science fiction is now part of our everyday lives. And it's being redefined, or it's redefining the technology ecosystem at a rapid pace. Right? There's massive investments in training and inference. Embedded AI and machine learning is going to a wide range of devices, and new software paradigms are also releasing at a rapid pace. With all these changes, your product and system architectures need to change too. And your test and measurement, and you personally need to adopt with it. I really believe the test leaders of tomorrow are the ones who embrace AI today. Now, I know that's quite a powerful statement, but I want you looking at that and saying, okay, how can I do it? How should I embrace AI? Well, I'm going to first say I think you need a trusted partner who can navigate this complexity, and we're ready to be that partner. We've got a long history of innovation. I've been fortunate. I've had 33 years of firsthand experience at NI as we've innovated. We recognize the power of PC across industries, and we brought PC control to test. We embraced the graphical user interface, and we redefined how engineers captured measurements with LabVIEW. We combined PC-based technology with programmable FPGAs, modular, high-performance architectures, and delivered you PXI and C-Series. But you did the rest. You took these products, you took these architectures, and you revolutionized the modern world. From smartphones to EVs to reusable rockets, none of them would have been possible without accurate, reliable test and measurement and your expertise. So let's build on this legacy. Let's build on your expertise, and let's do it again. Together, let's bring AI to our field. Now, what is AI? Right? It's more than chatbots and image generators. It goes from small-scale machine learning at the edge to massive cloud compute systems. It's driving changes in computer architectures as we speak. CPUs, FPGAs, and ADCs are being combined with GPUs and AI accelerators. And the result is a hybrid architecture that offers disruptive improvements. And these improvements are shifting the complexity of the products you test to the products you develop. From advanced autonomous vehicles to the latest smartphone chipsets to sixth-generation fighters, the technology landscape of 2024 is staggering. The systems are becoming increasingly software-defined, and AI and machine learning are being embedded in every layer of these products. This presents new challenges for test. We know you're going to need embedded machine learning, real-time adaptive test, system-level test, simulation, improved traceability, and so much more. And of course, your company, just like ours, wants that with a higher quality and a faster time to market. So you're going to demand a new approach to test so you can build these products in the future. And intelligent test is how we're going to meet that demand. It's easy for us to envision a future where all test systems are intelligent. Okay, so now what do we mean by intelligence? We define intelligence as the ability to perceive, learn, and adapt to optimize outcomes. What that means is your intelligent test systems can solve problems, improve productivity. They'll take data, algorithms, and domain knowledge and combine this together to improve your productivity. Over time, this will transition your traditional testing paradigms. It'll make test systems more automated, predictive, and adaptive. Now, I hope you're asking, okay, well, what does that mean in concrete terms? Well, first, intelligent test systems will be built on our world-class hardware and software that we've been delivering for 40 years. And we're going to keep on advancing them. But we are going to augment them. We're going to augment our hardware and software with first instrument intelligence. Instrument intelligence is distributing the decision-making all the way to the point of the measurement. Signal processing will be advanced at that point of the measurement, but also you'll be able to get real-time insights on the waveform features. This lets you adapt the test flow and actually lower your test time. We're going to augment it with user intelligence. User intelligence is really accelerating your validation and test workflows. It optimizes your test plans, and it gives you rapid data analysis and reporting. And finally, we're going to augment it with enterprise intelligence. So enterprise intelligence is really about aggregating your data together so you can get improved asset utilization. You can get manufacturing trends and defects, and you even get insights on your product lifecycle. Together, these will accelerate your time to market, lower your cost, and improve your quality. Now, we know there's work to be done to get there, and it's not going to happen overnight, but our direction is clear. We're committed to this vision because your products of tomorrow demand it. Now, with all this change, there's a lot to navigate. And we know we need to navigate this complex principle or complex future, so we're going to do it with some clear development principles. And we want to set the standard for development or AI development and test and measurement with 3 clear principles that I want to announce today. Our first principle is everything we do with AI will be expert-led. And by expert-led, you might have figured that out when I talk about your expertise, but it really is you are in charge. We're going to make the engineer be in the loop. You're always in control. You're always redefining the outputs. And AI is there to assist you, the expert. Secondly, they'll be AI enhanced. What that means is we're going to bring AI to the tools you use instead of forcing you to adapt to new technology or new separate interfaces. It will lower your learning curve, let you get rapid analysis and rapid insights, so you can get an impact faster and you can spend more time on the rewarding and creative parts of your job. And the last, and in really ways I think the most important, is industry ready. We realize that data and IP are the lifeblood of your company, and it is critical to protect it. We are committed to adopting the best practices in data privacy and security. We are going to partner with key leaders like Microsoft to make sure every tool we use is enterprise ready. We'll be transparent in our use of AI, we'll enable opt-outs, and we'll always have clear terms of data use and protection. We believe the heart of these principles is a deep respect for you. By empowering you with the right tools and insights, we can unlock the true potential of intelligent test, from engineer to enterprise. Now, we can't do this alone. In addition to working with lead customers like yourself, we also work with key partners. And NI has been working with Microsoft for many years. It's been one of our key partners, and their partnership is even more critical than ever as we bring about intelligent test. So let's learn more about how Microsoft is paving the way for AI in enterprise and industrial.
How do we empower every person and every organization on the planet to achieve more?
It starts with one.
From one employee to a team, collaborating with another team.
From one partner to their customers, to their customers' customers.
Your passion,
your ingenuity,
your hard work.
supporting inclusive opportunity,
protecting fundamental rights,
committing to a sustainable future,
earning trust,
for our society,
our economy, our world.
That's the impact. That's the impact.
That's the impact each of us can have.
That's our collective opportunity.
Empowering 8 billion people.
We're entering a new era of AI,
where we will be able to build as fast as our imagination,
where creativity will have no constraints.
And we can focus on the big picture.
Together, we can ensure these benefits reach
every country, every industry,
and every individual.
When we empower every person and every organization on the planet to achieve more,
we empower the world.
Please welcome to the stage Senior Director of Azure Data and AI at Microsoft, Matt Fingman.
Good morning, Austin. Man, test and measurement, folks, I didn't think you went so hard. Was at the party last night. Impressed. So welcome to the conclusion of season 1 of the drama-filled show called The AI Show and the start of season 2. It's been a little bit of a crazy ride, I'll be honest. As you start to think about the innovation that has gone on, it is amazing to watch the evolution of AI. It goes back all the way from artificial foundations in the 50s and the 60s, machine learning and the models that got created and those new patterns that were brought forward, deep learning, if you remember IBM and Watson beating Gary Kasparov, that was a seminal moment in some of these evolutions. All of these technologies have built on top of each other. Generative AI is very different. It is a seminal change that we're watching in the industry right now, and we're watching this become, honestly, a revolution. It, I believe, will truly be as large, if not larger, than the internet. The number of use cases that we're seeing developed with our customers and with our partners like Emerson Test and Measurement and it's amazing to see the level of innovation. I am so proud to have them show you the demos that are going to follow. It is great that they are using this technology to implement, to automate your space. One of the big items that you'll look at is, as you start looking at generative AI and start implementing these technologies, it's only as good as the data. And with that data is the foundation for all of the models. You have to trust that that data maintains in your controls. Your data has to be your data. That data can never get moved or retrained back into the model. That is an absolute. We have to make sure that also we protect all of the questions, the prompts that are asked of it. We have to make sure your test questions are your questions. Those will never leave your lab, your organization. That has to be one of the foundations, and that is one of the pillars where we are so aligned with Emerson. They are fully aligned with all of our responsible AI pillars. If you thought you had enough co-pilots right now, you don't. I had a meeting recently with Satya Mustafa, got to meet Mustafa. We're really excited about a lot of our new leadership that has come in and focused on this. And one of the statements that was made to all of the leadership that was there and working with them was that every piece of software we ship, every piece of service we ship, every piece of hardware we ship will have a co-pilot experience. We want, and are aligned with Emerson on this, we want to make sure that you have an assistant. We want you, people, to be involved in this process. We don't believe in just full autonomous. There will be items that we will automate, but we want you to have the assistance to tap into your expertise to empower your industry, your companies, and your products. Boy, this has evolved so very, very quickly. It all started from a cloud implementation. That's how Sam Altman and OpenAI, I really give them a lot of credit for the engineering work that they've done. It all started based on a cloud. It has innovated very, very rapidly. The reason why I call it a drama-filled season 1, GPT-3.5 was released, 4 Turbo. They just announced 4.0 Omni. It is amazing to see that pace of innovation that's gone on. But are any of my friends at Qualcomm in the room? Chef kiss, my friend. They have done some amazing work. if you guys have not seen the announcement Microsoft made yesterday about the new Copilot PCs, I get to talk about the branding. I've known about this for 6 months. It's been killing me. The work that the folks at Qualcomm have done is amazing. They have introduced a neural processing unit that will allow a language model to run on a PC. It will offload from CPU, GPU, and now with a neural processing agent that they've done, absolutely phenomenal work to the point of 40 teraflops in performance. So you will be able to have a local language model in your lab, in your environment, at your test workstation that is running and scaling and performing as you want, ensuring that all of that data stays in your environment. We also believe that the edge will be super important as well. If I've got a set of test machines in a lab, I don't want to have that data roll out to any other place other than my lab. We're going to also empower everybody at the edge as well, so that we can store that data and not call and round trip back up to the cloud. The pace of innovation is rapidly evolving. One of the big items, if you see the announcements that actually land today at the Microsoft Build Conference, I'm missing it today. It's our big developer love fest around how we're going to market and the big new announcements. Today, we announced a whole bunch of net new language models that are going to be available. Some from OpenAI, some from Hugging Face, Meta. You see this whole portfolio of language models that are out there. The big one that everybody's going to want to pay attention to is from Phi 3. It's a collaboration open source project that Microsoft has put forward, and that is some of the language models that will be available on the client. One of the big items that I was working with as we were starting to go with our AI core team, I asked them, hey, how are we making sure that we're going through and testing and doing all the detailed analysis of which models would work for the best use cases and which would be best fit for in an individual scenario or industry? And one of the leaders turned to me and said, Matt, we trust nothing that anybody says to us. We test absolutely everything. So you're going to see us provide transparency on all of our benchmarking. You're going to see us provide transparency on the best use of these use cases, the best language model for you to potentially implement. If you want to fine-tune something for your industry data, we want you to have that available to you as well. So with that being said, our partnership with NI is deep, it's long, it's storied. LabVIEW, it's amazing to see the heritage and the community that's available here. Emerson, if you buy in and work with us on this vision, we together can innovate faster than anybody can imagine. We want AI to be integrated into all of your products as well. It is amazing to see the power. I'm so proud to be able to make sure that we represent Microsoft and our partnership together with Emerson. Do not trust, test absolutely everything. Thank you.
We don't trust, we test. That's quite a statement. And I think I was right saying its technology is evolving. We got new announcements during the keynote. So wonderful. It's incredible to see the role Microsoft is playing and the leadership role they're taking in AI. And like I said, our partnership with them is even more critical than ever. But you're not here to just hear us talk about it. You actually want to see AI in action. Let's give you a sneak peek of some of the AI that's being done in our lab, or how we're using AI in our labs, and really highlight the impact of intelligent tests will have on you as a test engineer, a lab manager, or test leader. So with that, I'd like to introduce Michael Phillips, Senior Director of Software Technology, and Shruti Sherhati, Director of Application Software R&D.
Thanks, Kevin. Really excited to show everyone today what we've been working on in our labs. As you know, NI's existing hardware and software already accelerates your workflow, but we envision an improved workflow centered on your device and accelerated by AI. This is a workflow that is seamlessly integrated, improving your efficiency, your time to market, and your product performance. Today, we're going to show you how AI can improve building a test system, then how it can improve operating that test system, and finally, how it can power your analysis. The device we'll be using today is a high-performance RF power amplifier from Qorvo. These devices are like megaphones for radio frequency signals. They're critical in enabling communications, radar, and other wireless applications. Shruti will be playing the role of a validation engineer who's trying to determine test limits for manufacturing. Shruti, let's test our device.
Sure, Michael. So as you can see, I'm logged into Instrument Studio, and this is what enables the data and the decisions from every step of my workflow to be connected and managed. This is what centers the intelligence around me, the test engineer. Now, a typical starting point when performing a validation test is to reference a requirements document for the device that's being tested. So let's go ahead and use a prototype of an AI-powered requirements import capability in Instrument Studio.
So a challenge with requirements documents like this is you get something from a colleague, it doesn't have a common structure. So it can be really time-consuming and error-prone to go through it carefully and get what you need to put into your tools to have requirements. It may be a document, it may be slides, it may be a spreadsheet. Doesn't matter. Using Azure OpenAI from our partners at Microsoft, we can securely extract these requirements and enter them directly into your tools, being industry ready. Shruti, let's take a look at the document.
Sure. So a typical requirements document like this one contains information like the product overview, the test plan, the operating conditions, and the theory of operation. As Michael pointed out, the format and the contents of this document can vary pretty significantly depending on the customer, the industry, or even the team. So this AI-enhanced capability does not rely on any specific assumptions about the structure or the contents of the requirements document. As we can see, the import has completed, and on the left, we have a list of specifications that we need to test.
Wow. Did everyone just see that? AI just worked with that human-readable format that we gave it and instantly, invisibly, seamlessly integrated all of that into Instrument Studio. That's really AI enhanced. We just read an 8-page PDF, extracted what was important to test, and entered that data into Instrument Studio. Shruti, how long would it take you as a test engineer to do that?
So to read through the requirements document and enter all that data would have taken me closer to a day. And that's assuming I didn't make any mistakes or miss important details.
Wow, that's amazing.
All right, so moving along. As I click on the specification for small signal gain, we can see that the AI was able to correctly understand the operating ranges over which this specification is valid. And this is critical for auto-generation of future test sweeps. Now, keeping me, the test engineer, in the loop here is critical. We can see that the AI correctly pulled in the frequency operating ranges to be from 8.5 to 10.5 gigahertz. I am going to go ahead and extend that to go from 8 to 11 gigahertz to include a guard band and see how the amplifier responds. Also, because we don't have a temperature chamber here on stage, I'm going to unselect the temperature operating ranges for now.
So as you can see, like Kevin said earlier, this is all designed to be expert-led. You can review and edit what we get from the AI at every step of the way. Now, the next step in our flow here is to build a measurement. And the best way to do that is to create a test sequence. As you know, test stand is an incredibly powerful tool for building test sequences. Sometimes all you need is a simple sequence. So what we've done is seamlessly integrate the power of test stand into a simple sequencing capability right here in Instrument Studio.
That's right, Michael. Let's use AI to auto-generate a basic test sequence for us right here. Now, the next step for me is to go look for a piece of trusted IP that I can reuse to perform the small signal gain sweep.
So this is the part where you actually have to have some IP. Ideally, you don't want to have to create something from scratch. You want to reuse some existing trusted IP, if you can find it. The challenge is finding it. Do you wade through internal file shares? Do you ask a colleague? And maintaining an IP library like this is a hard problem. but we see an opportunity to build this up automatically with intelligence. And here we're showing an AI-powered semantic search that's been AI enhanced. Remember in yesterday's keynote how Eli showed you how we can actually create descriptions of LabVIEW VIs for you. Well, take that concept, add to it descriptions of other code and other measurements you have. We can store those in a vector database, and we can use that information to power a semantic search that can find what you need when you need it. One thing to note is Shruti didn't actually type in a search query here. All of this is gathered from the requirements document at the very beginning, so we know what you need. What we're going to use is the VNA small signal gain sweep, because we use that on a recent project. This gives me an opportunity to introduce a product, the new VNA instrument, the PXIe 5633 VNA. This pairs with a VST3 to enable S-parameter VNA measurements and modulated measurements in a unified instrument. Now, normally we would have needed to select hardware and set up channels by now, and AI could help you with that too. But for the sake of time, we're going to skip that part. Shruti, let's run the sequence.
Okay, so once I've had a chance to review and audit the test sequence that the AI generated for me, I can run it. And as I run it, we can see that the AI was able to take into consideration the power-up sequencing requirements for this device and auto-generate parametric test sweeps over frequency and drain voltages. And all of this from that requirements document.
Right, so not only did we actually bring in what we need to test, but how to test it, to safely power up and power down the device before and after, all from that requirements document. Getting this step right is crucial. If we get it wrong, it would invalidate our test, and worse, it could be catastrophic for the device. And of course, you can go into this sequence and check every step to make sure it's correct. Shruti, what's next?
So the next step is for me to publish this test sequence to SystemLink. This enables the rest of my team to have access to it and for me to be able to deploy this to a test station.
So now that we've seen how AI can help us build a test system in record time, let's see how AI can help us deploy to multiple test stations. Remember, our goal here is to determine test limits for manufacturing. To do that, we need a lot of data from many devices. So we're going to need to use multiple test stations. That way we can figure out high confidence test limits. Now, we don't have a validation lab here on the stage. So what we're going to do now is show you the flow for a lab manager to schedule and run these tests. So after we add the rest of the characterization tests beyond small signal gain, we're ready to schedule. Now, the AI knows which systems are suitable to run this. They have the right hardware, so we're going to select those. And we're going to test in Austin on all of our devices. And we're in a hurry here, so let's move to the front of the line. Now, one challenge is these are shared resources. There are countless combinations of all the things involved to schedule your tests. There's the equipment, there's the lab space, there's the operators, and there's the power management. And for all we know, someone called in sick this morning, and we need to have a schedule that optimally uses those resources. This is like solving a jigsaw puzzle with 1 million pieces. This is like finding a needle in a haystack.
Michael, I think our audience gets it. But how do we solve this?
Well, fortunately, we can apply intelligence here too. All you have to do is click Auto Schedule, and we bring AI to help you optimally use these resources. So now you can see, yes. Now we can see our tests have been scheduled to run first, and others have been intelligently postponed. And of course, you can look at that and change anything to meet your needs. It's expert-led. Resource deployment and scheduling like this optimizes your equipment and your operators. Further, SystemLink can handle deploying the software and the dependencies correctly so that you get speed and consistency of those results. Okay, next, let's fast forward. All of these tests are done. We have results from 100 devices. Let's see how AI can enhance measurement data analytics. Shruti, are we ready to analyze the results?
We sure are. So all analytics begins by having sufficient quality and quantity of measurement data. And oftentimes, it is finding this measurement data that is the hardest part because of it being stored in a variety of different formats and across so many different test machines. The context and the intelligence that travels with me every step of my workflow makes it easier than ever to find this measurement data. So what I have pulled up here on screen is test data from the small signal gain sweep that we ran on the test stations, specifically for the 16-volt drain voltage. Now that I have the measurement data that I care about, we can start to run some powerful analytics on it. We envision being able to offer large libraries of statistical and AI-powered analytics. But for now, my task at hand is to get to a test limit. And that is the option that I'm going to select.
So determining test limits is a complex statistical calculation. It involves data from multiple sources. First, you have the product requirements, which we brought in through that document at the beginning. Then you have the measurement data that you've collected, which we just got. But then you also have the instrumentation uncertainty for all the devices that you use to gather that data. Lucky for us, all that information has been connected and it's ready to be leveraged with intelligence. This enables Shruti to recommend test limits with expert desired confidence that the manufactured population will be better than the limit.
That's right, Michael. So starting with my measurement data, I have asked the AI to give me two separate outputs. First, for manufacturing, to ensure I have good yield, I have asked the AI to recommend a test limit that is at least 4 sigma from the mean of my verification data. And second, I have also asked the AI to advise me on where I can safely set my typical published specification. Now, looking at the output that the AI has provided, as a test engineer, I'm likely to go with a more conservative 28 dB for my test limit. However, I am seeing that what the AI is recommending as the typical published spec is slightly lower than marketing's requirement of 33 dB. I wonder if the AI could also help us there.
Maybe so. So just to recap this whole process, we started with a requirements document that we got from a colleague. We used that to determine what IP we needed to test, found that IP, and then were able to run a sequence, bringing up and bringing down the device properly, then schedule that to run on multiple test stations on many devices. Then we analyzed the results to determine high confidence test limits. AI accelerated every step of that process. Connecting our tools with information about your workflow and your product to emerging AI capabilities will rapidly improve your efficiency and your insight. This demo, where we accelerated building a test, managing the operations, and performing the analysis, is just a sample of what we're doing in our labs. This is an exciting time in test and measurement. AI is advancing at an incredible pace, rapidly transforming how all of us work. And we're ready to partner with you to unlock the potential of intelligent test. Thank you.
Thanks, Michael and Shruti. Well, that was magic. It almost looked so simple, but I guess that's the power of AI. What you saw was roughly 2 days of work in 15 minutes. Now, if you're like me, you're probably doing the math on that and saying, wait a minute, is he saying AI will be, 60 times faster? I'm not quite saying that. I want to be clear. But maybe for the old NI customers, 10x for test should be back. So, what you saw was expert-led at every step of the way, with Shruti coming in there and being able to audit it. It was AI enhanced as we brought it to our tools. And of course, all the tools we use behind the scenes were industry ready. This is just the beginning potential of AI for improving your productivity analysis as a test expert. We believe in our vision of intelligent test. We believe it will transform the way you bring products to market. But before we go, I got one more thing. I'm an engineer at heart, and I'm still wondering, why was that only 32 dB? One of my favorite things was going to a whiteboard and trying to solve problems of the unknown. Why? What if? What could we do? Could AI be that partner? Well, in the final demo of 2023, Alejandro Barada, he gave you an early preview of AI chatbot called Nigel. Well, Nigel keeps advancing. You saw it yesterday in the preview, but Nigel even has more skills than you've seen. So I'd like to show you Alejandro exploring the idea of AI emulating the at-the-whiteboard experience.
Well, let's explore this idea together. So I've loaded up the data that Shruti ran on stage. It is the small signal gain for our amplifier. We're characterizing the performance and the test limit for this amplifier. And I'm wondering, can we do better? I see this faint line here. I'm just going to draw this arrow here. Say, hey, Nigel, why is this so low? And just a heads up, we're going to speed up this video in the interest of time, but everything you're seeing here is real. Okay, great. Looks like the AI replied, and it's telling me that this faint curve could be because of a variety of factors, such as variability in the DUT performance, or measurement errors, perhaps at the test station, and that this curve is actually potentially bringing down my limits. And it's telling me that to further investigate, it might be useful to examine the distribution of small signal gain values more closely. So let's do that. Okay, well, the AI replied with a distribution of small signal gain around that frequency, 8.5 gigahertz. And I see here this distribution is bimodal. So I'm just wondering, I'm just going to circle these samples here and ask Nigel, examine why these samples exist. Awesome. Well, it looks like Nigel created a distribution here of the small signal gain around the frequency that I had placed my arrow. And it's giving me some statistics. But what's interesting are these observations here. So it's saying here that all of the samples come from the same test station, TS002, which might suggest a station-specific issue. And that, furthermore, there are 25 different DUTs in these samples. And that might indicate that the issue is not isolated to a specific device, but could actually really be the test setup or the conditions at the station. And it's suggesting that we should examine this station. Let's ask the AI to plot the gains for all test stations for all frequencies. Great. So it looks like the AI created a chart here plotting the gains across all test stations at all frequencies. And we can see here that test station 2 is definitely lower for all the measurements. So something must be off about this test station. Perhaps it's a loose cable. We're going to have to investigate that. But for now, let's just ask Nigel to redo the first chart with the test limits, but without TS002, and show me the improvements in the performance and limits in a table, if any. Awesome. So it looks like excluding the bad test station led to a 1 dB increase in the amplifier's gain. The typical performance now rounds up to 33 dB, and that's a better number that we can include in the data sheet. This more precise characterization of the gain is a big deal in RF applications where every decibel counts. So what we just saw was that the AI analyzed our measurement data, crunched some numbers, and helped us diagnose an issue at the test station, all of which led to a better characterization of the device, which I know your customers will love, all without breaking a sweat.
Pretty incredible. AI can even find a loose cable. So that was a video of Alejandro. But if you want to see him live and in person, at 1:30 today, he's in the Ask the Expert section. If you want to see how we did that and how we do other things, go there and ask him some questions. It's incredible to see where intelligent test can go. We've shown you today is really focused on the user and the enterprise aspects of it. But this is just a portion of our research. We're exploring far broader capabilities of intelligent test. We're looking at instrument intelligence and how we can adjust decisions dynamically based on device-specific data. We're extracting features through embedded waveform intelligence, and we're improving design through simulation and digital twins. These give you an idea of the broader impacts this technology can have from engineer to enterprise. So whether you're working on the latest smartphone chipset or the next generation medical devices, intelligent test will disrupt your market. The future of test is exciting, and we're building it faster than ever, one innovation at a time. Thank you. Enjoy the rest of NI Connect.